Hello and welcome back to Pre-Algebra with Miss Betsy. I'm glad you're continuing along with us as we have another lesson where we are working with finding the percentage of increase or decrease when it comes to word problems. Now, if you're using the same text that I'm using, I'm in Chapter 10, Section 5. It's entitled Percent of Increase or Decrease. The text that I'm using is Pre-Algebra for Christian Schools. It's published by Bob Jones University Press. I'm using the first edition, and we are on page 325. My infamous lame joke for the day. How can you tell when an elephant is getting ready to charge? Well, it's easy. It's when he takes out his credit card. So you can look and see that I've already written quite an amount of information on the board here. We're finding the percentage of increase or decrease of one quantity over another. And another way to describe finding the percentage of increase or decrease is just to call that finding the percentage of change. Change can be positive change, where something is greater than what you began with. It can be negative change, where the end result is less than that which with you began. And what's interesting about change is an increase is not always a good thing, a decrease is not always a bad thing, but that's how they define increase and decrease when you're talking about percentages. Is increase is a larger number, decrease is a smaller number. An example of where an increase would be a bad thing would be sometimes in a white blood cell count. I guess that's going way back to my history in the medical labs. When you have an elevated white count, that indicates infection. It indicates your body's working properly, but a good result is not to see an elevated white count. So, anyway, we want to find the percentage of increase or decrease of one item with reference to another. And our problem here begins by saying, Mark earned $25 per week mowing lawns last summer. This summer, he will earn $40 per week. What's the percentage of change? Now, $25 a week increased up to $40 a week was really, really good money when I was young. Now it would not be so good of an income at all, but we can still use this problem as a good example, good illustration of how you find the percentage of increase or decrease. There are really just two steps involved in doing that. First step is we're going to subtract the two quantities to find the total amount of change. Okay, he's starting, let me use a different color marker here. He started last summer, he made $25 a week. Let me glance and see if that's actually going to show up. $25 a week. He is making $40 a week this summer. We're going to subtract them, and we're going to subtract so we have a positive number. So 25 minus 40 would give us a negative 15. So we're just going to say that 40 minus 25 is $15 change. Now we're going to look at this. His original amount was $25. This year, this summer, it's going to be $40. So he has a $15 change, which would be a $15 increase, because that from last summer to this summer, his money has increased. There is a regular formula that you use to solve percentage of change, percentage of increase or decrease problems. You set it up just like this. What percentage of the original amount, can't speak today, what percentage of the original amount is the change? So you just set it up exactly like this. WP, what percentage of the original amount, the original amount was 25, equals the change, was a $15 change. Now what your book shows you is just writing it out just like this. They're illustrating it to you how you take it from words into an algebraic sentence. And they're saying, let's have n be our variable that we're going to use for percentage. What does of mean? It means to multiply. N times 25 is equal to 15. And I'm going to go ahead and take the time just to step through it with that x in there. Those of you who have my class know that I'm saying lose that x because x is a variable. We're going to use something different to indicate multiplication, but just for the way this text is stepping through it, I want to go through and show you exactly what they're doing. That's on page 326. N times $25 is $15. I'm not going to go ahead and keep the dollar symbols in there because you don't need to have those showing when you're actually calculating your problem. We know that we want to find out what that percentage is we want to solve for n. What we're going to do here, since we multiplied by 25, we apply the inverse operation, and that tells us that we can divide by 25 to undo that multiplication. So we divide both sides of the equation by 25 because that's how we're going to keep our equation in balance. When you do that division off to your side, you have done 50 divided by 25, 15 divided by 25, and you end up with 0.60. And you learned earlier in this chapter, or earlier in your involvement with arithmetic and pre-algebra, that percentage can be expressed as a decimal number, that 0.60 is the same as 60%. So what is n? N is 60% increase. Because our problem asked us to find the percentage of change in the guy's income from mowing yards. We said what percentage of our original amount of $25 is represented by the $15 of change. Calculated that to be 0.60, and we recognize that 60 hundredths is the same as 60%. And we saw that this was a 60% increase because his income last year was $25. It went up to $40. So he showed from one summer to the next a 60% increase in his income. So now let's go ahead and do another problem where we are calculating percentage of change. See if I can erase this very carefully here so I can keep my little formula, little sentence written here. See what our next question says. This says, find the percentage of change. Write and solve an equation. Indicate if it's increase or decrease. The original amount is $400. The new amount is $340. The original amount was $400. The new amount was $340. How are we going to find our percentage of increase or decrease? Our rules tell us first we're going to subtract the original amount and the new amount to find the amount of that change, and we're going to know if it's increase or decrease. What is 400 minus 340? Well, that's $60. So we have a $60 change. Now, is that increase or is that decrease? Well, obviously, if you start with $400 and you end up with $340, you have decreased. So we've already answered part of our question because our question said indicate as if it's an increase or decrease. So we already know that we have a $60 decrease. And in this case, a decrease might be good. Maybe something that was important for you to buy cost $400. It's on sale for $340. So it dropped $60, which we're going to find out that this should be 15%. So how are we going to go ahead and figure this out? We've already found the amount of change. Now we're going to find the percentage of the original amount represented by the change. What's our original amount? What percentage of $400 is the change, which is $60? Now we saw last time that they simply would have said n times 400 is equal to 60. We're going to go ahead and make that a little bit more looking like an algebra equation. We're going to say 400n is equal to 60. Because you've learned that when you have a number bumped right up against a variable, that means 400 times n. Now what does your book show? It says n times 400. And you know that multiplication is commutative. You get the same answer whether you say 400 times n or n times 400. And this is how we, in algebra, typically indicate multiplication that involves a decimal. We don't go nx 400. We say 400n. Okay, what are we going to do now? Well, yeah, that's very, very straightforward. We don't care about 400n. We care about what 1n is equal to. We're going to divide both sides of this equation by 400. You can immediately divide by 10, and you have 6 over 40. Then you do your long division, which I'm not going to take the time to do, and we're going to have that n is indeed equal to 0.15 1500ths, or 15%. They said, make sure you indicate if it's increase or decrease. If you just said n is equal to 15%, it would not be completely right because it's a 15% decrease. So make sure that you label your problems and your answer correctly. N is equal to a 15% decrease. When the number dropped from $400 to $340, that 60% change indicated that the price or the amount dropped by 15%. So perhaps this item had a sale going on. It said 15% off the original price. Now, how did I figure out in my head that it was 15%? Was it because I'd already read the book? No, it's because it's easy to do 10% of something. If you tithe, you automatically know that you drop a zero. So 10% of 400 is $40. 5% is half of 10%, so half of the $40 is 20. 40 plus 20 is 60. That's how I knew that $60 was going to end up being a 15% decrease. And the more that you practice working with some of this mental math, the easier it will become for you. And really using 10%, you can come up with really good estimations all the time, because it's easy to figure out what 10% is, what 1% is, what 5% is, and you can just practice, even when you're checking out at the store, practice rounding numbers and add them up in your head, see how close you get to what the cashier says. The state that we live in, we have 8.25% sales tax. You can estimate what your tax is going to be on an item by saying 10%. Just these little mental tips and tricks will help you to be able to function more knowledgeably as you're out and about in your world. Okay, that was totally free mental math. Let's do another problem. This time, we're going to see an example of how you can simply use a ratio, a proportion involving two ratios to solve these types of problems. We solve these types of percentage of increase or decrease. And we're going to have 100%. We're going to have to deal with our original percent. What three pieces of information do we have here? We have what percent, original amount, and change. Okay, so we know that a proportion involves two ratios set equal to one another. So let's take this one here and think what we're going to be. Well, is it going to be what percentage you know what, this would be a really good time to have a pause on my record thing, which I don't. Let me go ahead and keep right on going. Maybe I'll take the time to edit this out. Probably I won't. Let me go ahead and erase the rest of this instead of trying to tie the two together. We just go ahead and track exactly the way our book is. Our book tells us you can also use a proportion to find the percent of increase or decrease. We want to find the percentage of change by writing and solving a proportion. We want to indicate the amount of increase or decrease. And they're showing us the original amount and the new amount. So the original amount is $80. The new amount is not $50, I believe it's $54. The new amount is $56. What do we do first if we're going to find percent of increase or decrease? Number one says subtract to find the amount of change. So the amount of change is $24 because 80 minus 56 is 24. If our original amount was 80 and our new amount is 56, then that's a decrease, isn't it? So we have a $24 decrease. Let's look back at our problem. This is example 2 on page 326 and 327. Find the percentage of change, write a proportion. Does it indicate increase or decrease? So we know we've got a $24 decrease, but we have to convert this into, come up with an equation, come up with a proportion in this case, that will tell us what that $24 represents percentage-wise. So first we're finding the amount of change by subtracting, gave us $24. Next, we want to solve a proportion, which is where I was starting to write earlier when I said what percent of 100, what percent of 100 does this percentage of change, this amount of change, represent of the original amount? See, we have the same pieces of information. We had what percent of the original amount equal the amount of the change. So we've just set this up slightly differently because we're setting this up as a proportion. Can just use n or x to be the variable that represents the amount of change. So we're going to have x over 100. What's the amount of our change? $24. Set to the original amount of $80. And the reason we like to use these proportions is because when you have a proportion is simply a statement that tells us the two ratios are equal. Then you can use cross multiplication. Remember, we have cross products. 80x is equal to 24 times 100, which is 2400. You go ahead and divide both sides of this equation by 80. Divide both sides of the equation by 80. When you calculate that math, you end up with x is equal to 30% decrease. That's all that's involved in solving percentage of increase or decrease problems. Just 2 steps. You have to subtract your original amount and your new amount so that you figure out what the amount of change is. The change is either going to be increase or it's going to be decrease. And you need to indicate that specific piece of information at the end of your problem. And then you want to find what percent of the original amount, find the percentage of the original that is represented by the amount of change. What percentage of the original amount is represented by the percentage of change, by the amount of the change. Practice these. Some of you may like setting up proportions. When you set up a proportion, you're trying to find a percentage, some unknown percentage of 100, and the relationship that you set up for that second ratio is the amount of the change, not the new price. It has nothing to do with the new price. It's the amount of change divided by the original amount. This piece right here, the amount of change, that's what you have to be careful to calculate, because your problems are not going to give you the amount of change. Typically, they're going to say, here's the old price, here's the new price. What is that percentage of change? You have to figure out how much the amount of the change is before you can find the percentage of change. So let's go ahead and do one more problem. Just pick one from our book. Let's say that we have an original amount of 40, new amount of 42. Original amount is 40, the new amount is 42. What's the amount of the change? $2 change. We'll just assume these are dollars. Is this an increase or a decrease? It's an increase. The 2 ways that we could solve this problem: what percent of the original is represented by the change? What percentage of the original, 40, is represented by the change, 2, right? 40x is equal to 2. If you're still using that old Saxon math type style, or if you're using how they're just showing you what to do this, you could say nx40, divide both sides of the equation by 40. Work really rapidly at getting to where what percent of 40 becomes 40x. 40x is equal to 2. We want to divide both sides of this equation now by 40. And we see that x is equal to 0.05, which is equal to a 5% increase. And this is what this problem would look like if you set it up using this first method that we used. Second way that you can do this is to set up a ratio where you're finding the percent over 100 that is represented by the amount of change over the original divided by the original amount. 40x is equal to 200. X is equal to 200 divided by 40 our x is equal to a 5% increase. I'm looking at this right now. Looks like that's not quite showing. 200 divided by 40, of course, is equal to 5% increase. Make sure that when you're doing problems like this, that you convert the 0.05 decimal answer into a 5% increase. That's all that's involved in this section. Go ahead and work these problems. If you have any difficulties, send me a text, and I'll see you next time.